Good morning. Bonjour. We've had a little bit of chance to sort of dance around the edges of capture-recapture. We looked in quite a bit of detail in the linkage problem in a number of great presentations. I'm glad to say this will say nothing about the linkage problem. I'll put a little asterisk on that. There's one little slide that I actually changed because it talked how one person addressed this. It gives a good example. So I actually took out his results and put in his stuff for the linkage. But apart from that, so we're going to be talking about capture-recapture, specifically in social justice research, which is having quite a great deal of impact. If you look at producing the academic results, those are very useful. Capture-recapture very often in social justice is used to measure, its results have been seen in convictions of bad actors, in policy changes, and government, and this particular technique seems to do a good job of going beyond academic research to go into policy and other impacts. So first we're going to talk about what this is. You know, I don't think we've ever gone through so far. We've talked about some of the problems with it. Let me ask, how many people are familiar with capture-recapture and how it actually works? We've got a few, a smattering, but if you'll forgive me then if I do give that explanation, I won't cut that short. Capture-recapture and social justice, some prominent examples. What we're going to use to illustrate this method, it's just one example, and something fairly new, but something I've been working with the last year and a half. Hate speech and social media. We're mining various social media channels for hate speech. We'll talk about how we mine it, how we define hate speech, and then we'll use Bayesian methods to, well, for one thing, we're going to do that we could not do by any other means is produce a time series analysis of hate. We haven't been able to do this before. The introduction of Bayesian methods has allowed this, and we'll give some conclusions. So capture-recapture, well, that's what some folks call it, but you'll find other people might know it by this name. And some other folks know it by this name. And what it was originally known as, well, pick the name you want. For the purposes of this talk, it's capture-recapture, but it's all the same thing. Now, capture-recapture, the core notion of capture-recapture is estimating a population size using multiple independent samples. That's the one thing to take to the bank. What is this capture-recapture thing? What are we going to do with it? We're going to estimate a population size based on multiple independent samples. We'll talk about what those samples will be like in just a minute. It was originally developed a long time ago. We're talking 1896. Somebody used it to count, well, a fish. So the origin is a fish story. This is the European place. It's found in the North Sea, North Atlantic, in the Mediterranean, and if I understand it correctly, is occasionally found on people's tables hereabouts. Is that correct? Anyone commented they've seen any flounder around? So certainly when we look at the origins of capture-recapture, this particular method has its place. And people continue to measure these populations. And so in this case, we've got a 1996 study, which coincidentally is 100 years after the first measure of any population. So 100 years down the road, people are still using this method to count populations. Well, now, if counting the population were easy, you'd just count them, wouldn't we? And so one thing that's implicit here, if we're going to use this method to count populations instead of just counting them, we're going to estimate them. So what we're really talking about is hard to count populations. When do you use capture-recapture? When you have a hard to count population. And here we have an example of one of the classic examples is we're counting fish. You don't know literally how many fish are in the sea, but we can find out using this method. Patrick Ball, who we'll talk about more, I think a couple other people have heard about HRDAG, made a great deal of progress. He described capture-recapture, which he used to count and track the Bosnian genocide in the early 1990s. He described capture-recapture describing fish, and here's the story. How do you count the number of fish in a lake? You can't see all the fish. We'll go into more methodology in a minute, but this fish example is something that's widely used. It's being used to count many different populations. In fact, I'll bet that practically everybody here has seen a capture-recapture. They just didn't know it was capture-recapture. Anybody see this one before? You know how the hare population goes up and down and the lynx population goes up and down and they track each other and the lynx population lags a little bit? We've seen, where'd the population numbers come from? All the data in this very familiar study is capture-recapture data. So this is something where we've seen the data. People didn't go out and count every lynx in Arctic Canada. They use capture-recapture or capture-mark-recapture. Marking is especially important. We'll talk about how that gets done. But it's a very familiar story. Capture-recapture is going to show up in places that we've seen the stories before. We may not know that this particular method was behind the data. It was originally developed to count animal population. We mentioned the fish. We've got the classic story of the hares and lynx. It was developed originally to count biological populations, some of which can be very difficult to count. Recently, and especially because of the groundbreaking work of Patrick Ball and Human Rights Data Analysis Group, or HRDAG, what they call it, because of that, it has moved very, very strongly into the social justice area. And it's become one of, since the 1990s, has become one of the most important tools that we have in social justice. So here's the basic idea. What we're going to do is we're going to estimate the size of hard-to-count populations. Give you a couple of examples. Victim counts. Human Rights Data Analysis counting victims of various sorts, people killed, other things that happened to people, forced migrations, buildings being burned down. We had an example earlier of, in that case, it was satellite imagery finding burned villages. Well, I suppose they didn't capture every single village that was burned on the satellite images. Perhaps capture-recapture could be used to count that. So victim counts are one of the ways this gets used. Is one of the first uses in social justice. Underreporting. RTI International recently completed a great study. They're continuing to move forward. Deaths in police custody. We're going to look at that one a little bit more closely. But in this case, the problem is the actual numbers are underreported for whatever reason. In this case, when someone dies in police custody, it turns out the police might not actually tell, the local police might not actually tell the federal government. That sometimes that happens and sometimes it doesn't, and a lot of times it doesn't. So it's a serious underreporting problem. Ecological risks. Sometimes you can't see ecological storm clouds on the horizon, as it were. Give you an example. This method is now being applied to anybody here, we'll find out how many folks are in the United States. Anybody hear of something called the Flint water crisis? Wow, a bunch of folks. It's actually gone international. Okay, so I'll try to make a long story very short. The story is the local beaks in Flint, Michigan decided to save a few bucks when the city of Detroit, which has a regional water system, City of Detroit jacked up the prices. The city on the edge said, forget about this. We'll just cut this off. We'll go back to getting the water the old way, which we're pumping out of the river, send it through water processing, and put it into the pipes. The problem is they screwed it up, and the pipes, which were lead with a coating on the inside of them, because they didn't treat the water right, the coating got stripped away and there was lead in the water, and it's caused a lot of problems. Well, not every pipe is made out of lead. And so if you're going to have to replace all the damaged pipes, how many? How much will it cost? Are you going to dig up the entire city to replace the 60 to 70% that are lead pipes? Some are other materials. Most cities, especially if they grow, are a museum of infrastructure technology from long ago to most recent. So, this method is being used to find the number of pipes that have to be replaced based on samples. And so you don't have to dig up the entire city. You can get, there are other ways to actually find which pipes are bad, but to simply create the scope so you can have a government program and go after this problem. It's a hidden problem, and we can use sampling to find out just how big that problem is. Language barriers, community outreach. One of the things that we do a lot in social justice is you might find some local group or agency going door to door and they're talking to people, and what if they don't speak the language you speak? Well, if there's enough of them, you might go out and get one or two people that speak the language. In the United States, the most common language is English. You have, especially in some neighborhoods, especially in neighborhoods where there's a lot of need, you can have a lot of people speaking Spanish. It creates a barrier. The Spanish-speaking population gets undersampled. I'm sure you're going to find the same problem with other languages in other places, but you can find the total number of people in need despite having a low population or undersampled, because you can take that sample, take multiple samples of the same undercounted population, and we can estimate how big that population really is and how many people need support. Methodology. So how does this thing actually work? Well, the basic idea is you're going to do a sample. You're going to capture animals or killers or whatever you want, and you're going to mark them and so that they can be identified later. It has to be unique ID. And then at a later time, we'll talk about how much later is later. Has to be long enough, but not too long. We'll talk about that problem. But later you'll go back, preferably even by a different method even. We apply this in the hate example here. Go back by a different method and you take another sample. So you've got two samples. And here's the thing. All the people that you marked in the first sample, you're going to pick up some of them in the second sample, but not all. So the second sample is get a fraction that were previously captured. The previously captured sample is the linchpin to this process. So since the number of marked ones in the first sample, the percentage of the total population, was also the same percentage at the second capturing, well, we can write out the formula, we rearrange it. What it works out to is this. The size of the population is estimated as the number captured the first time multiplied by the number captured the second time divided by the number captured both times. That's the basic concept. As Patrick Ball put it, this is a really good example. He's working with Bosnian genocide. How do you describe your methodology? I love this as an example of describing methodology to someone who's a non-statistician. He's trying to count the number of people who were murdered in Srebrenica and where and when, and trace it and do a time series analysis. And he's trying to explain to people who are lawyers and attorneys and judges at the International Human Rights Tribunal in The Hague. And they don't know capture-recapture. He describes it this way. How do you count the number of fish in a lake? Well, you go fishing, and it's catch and release. You tag them, you throw them back. And then you go fishing another time. In fact, if you do it best, do it a little bit later, but maybe a different method. Maybe you were using a rod and reel and pulling fish out one at a time, and the second time you used a net or something like that. If you want to have independent methods. You want to make sure you get independent samples, because if the second sample is simply a clone of the first, it's not going to help you. So you'll go fishing one time, you go fishing another time, and the number of fish in a lake is the number of fish caught by the first team multiplied by the number of fish caught by the second team divided by the number caught by both. And you know which ones they were because you marked them the first time. You only have to mark them the first time. So what are the ground rules? Where can we go right and where can we go wrong? What are the things we have to watch out for to make this process work? We need a well-defined closed population. So we want to make sure we have a population that have boundaries on it. We know what group of people they are. And you can't have a whole bunch of people moving in and out. The question always comes down to what's the difference between sample 1 and sample 2? You want to make sure they're both looking at the same population, not different populations. So if the population is very, very rapidly in flux, this isn't going to work. Unless things happen very, very fast. And we'll see an example, because things can happen very fast on the internet. So a closed population and well-defined. We need to be able to describe in advance exactly what we're measuring. Be very, very clear about that. We'll see an example with Twitter hate speech. We're not going to find every hater in the world. We're going to find the people who are participating in social media and hate others, or at least have idiotification of death threats. Gee, I wish somebody would go out and kill all of those class X. We have several classes we're going to look at. This is not a pretty picture. This is what we're doing in social justice here. So you need to have a well-defined population. In the Twitter example, we need to be clear that we're not counting every hater. We're counting people who will participate in social media, whether they actually tweet their hate or not. So we get and what you get is actually, in this case, it's slightly nebulous. But if you want to count all the fish in the lake, well, sure, count all the fish in a lake. You know, sometimes people have trouble identifying a species. So if you wanted to do place versus some other bottom-feeding fish, you'd have to be very, very careful that you're only counting that particular fish. And then sometimes there's uncertainty. It's like, I got half a fish here and it's old and beat up and I'm not quite sure which one it is. You have to be able to deal with these situations to get a good identification. Capture probability has to be the same for all individuals. Doesn't work without that. So we have to think about that. This usually isn't a problem, but we want to make sure that there isn't some subset of people that we're interested in with a very different probability of being captured. This can be a problem if you're going door to door knocking on, hey, anybody hungry here? Or if after an earthquake, is there anybody in this building? You might find some parts of the area affected by the earthquake. You're trying to find the total number of earthquake victims. Well, if a bunch of people have moved out, it can be hard to count that population, but down the road where there were better buildings or less of an earthquake, then you might get oversampling there and it throws off. You need to be careful that the likelihood of being captured is the same for all individuals. Marked individuals must be free to mix with the overall population. So the idea is you're going to catch some, mark them, disperse them into the population, and they'll all mix around. Now, if I were fishing between 9 and 11 this morning, and then went out between 2 and 3 this afternoon and went fishing again, that might not be enough time for all the fish to mix in with all the other fish. On the other hand, remember when we said a closed population? You can't have a whole bunch of folks coming in. You can't have a whole bunch of folks or fish or what have you going out. And so what you end up with is there's a critical time period. A lot of this method comes down to finding the right time interval. You want to have enough time that the guys you captured the first time really do mix in with the rest of the population, but not so long that a bunch die and new ones are born or enter the population. It's always a competition. This will never be perfect. The shorter you go, the more closed the population is, but there's less mixing. So you need to be able to understand the population, work with your domain matter experts, and they'll be able to tell you that if I put, 200 fish at this end of the lake, how long before they're evenly distributed over the whole lake? Is that like never, or next year, or next week? Work with the domain matter experts who understand what the story is there on this particular question, so they can understand that they're properly mixed between the population. and yet not so long that you begin to lose individuals. You want to make sure that all the ones that were tagged, they had a same chance of getting captured in the second sample. And the marking process does not impact individuals. This goes, actually, this is another version or species of closed sample. If the marking process kills the fish or people or what have you, well, you're not going to pick them up in the second sample. Or if it has other impacts. It needs to be very important. This is particularly a concern with ecological instances where you have animals being counted. You want to make sure that the animal doesn't get sick or fail to reproduce or all the different things. So when you think about tagging means, you want to have the minimal impact that still allows them to be recaptured without them being recaptured selectively because they got tagged before. All the times I've talked about capture-recapture, notice I've talked about the first sample and the second sample. Life is not so simple. But to make difficult things easier, we've got Bayesian analysis. Supports repeated measures, multiple methods. So when you sample again and again and again, not twice to do the study, but you might find somebody has already done the sampling for you. And we're going to do this year and this year and this year and this year, or month or week or so on. In that case, if you have repeated measures, now Bayesian is going to not only allow you to deal with that repeated measure problem, it's actually going to get better because, as you know, of course, informed priors, we all know Bayesian. So this is where I talk to frequentists for 20 minutes and you all have the story. So the more samples we take, the more accurate the estimates get. So this is a perfect match for Bayesian analysis. Bayesian improves estimate accuracy, because as you do multiple samples, or simply even if you just had two, Monte Carlo simulation, especially using Bayesian methods, is a really good way to improve accuracy over pure frequentist methods. We had a number of people talk about capture-recapture, and they worked on the linkage problem and other aspects of it. This is the first time we've talked in this conference how capture-recapture actually works and give some concrete examples of it. There are things that can be done, but the basic notion of capture-recapture is if you compare it to frequentist means of, like just taking a survey, for example, you're going to get more accurate numbers, you'll get smaller standard errors, smaller standard deviations, you'll get a more, even if it's just two, first sample, second sample, Bayesian is going to perform better. And then, especially if you can do repeated measures, Bayesian continues to get better. In fact, it can be basically required for repeated measures. Give you an example. We'll jump ahead a little bit. One of the things I'm working on right now is trying to count human trafficking victims. There are a number of people who are victims of human trafficking that we don't know about. And this is a classic problem of underreporting. What there are a number of agencies that are working to support victims. You've got this social service agency, and you've got this group of people over here, and this group does counseling, and this group has a shelter, and this one's government, and this one's secular, and this one's faith-based, and you've got all these overlapping groups in any large area. You can have multiple groups. For example, the group I work with is the Michigan Human Trafficking Task Force. There are more than 30 different agencies all working directly with individuals. And because of that, because these are people, they have lists of the people they have contacted. They've effectively already done the sample. But there's 30 different ones, and there's tiny bits of overlap between the different ones. And instead of having sample 1, sample 2, 25% overlap, A times sample 1 times sample 2 divided by the overlap, and there's your population. Bayesian analysis is especially important when we've got these repeated measures. Repeated measures can show up principally in two ways. One is multiple overlapping agencies all counting the same thing, or at least having counts or population lists, and repeated measures over time. Let's do it next year and the next year and the next year. If the population doesn't change a huge amount year by year, that's going to be a good use for Bayesian analysis. And because of that, because it works so well for repeated measures, especially repeated measures over time, it's going to do a much, much, much better job of supporting population trend analysis over and above frequentist methods. So if you really want to know how things are going over time and how they're changing, you really have to go with the Bayesian analysis. A couple of applications. Well, we've talked about the Bosnian genocide a few times. So I'm not going to talk about it anymore, despite the fact that they had a huge impact. They actually used statistical analysis to have a huge impact to put people in jail and connect the dots. But we're not going to talk about that anymore. We're going to talk about how Patrick Ball and his team did the linkage problem. And what they ended up with is they looked at all the different ways they could identify a person. They got 25 different ones. They got named in different things. Then they made a decision tree to find the things that made the most difference. And the decision tree analysis got them, it was 99.8% accurate compared to hand matching. So this worked really well. So when there's a number of different ways you can identify, capture-recapture, mark individuals, versus just hand counting people, hand matching people, very, very labor intensive. That this decision tree process did a lot to improve the matching process. So this is one possible approach. I used to have a slide here on the HR DAG and the Bosnian genocide, but when I heard people talking about the linkage problem, I wanted to put up one approach that this is the one that Patrick Ball used. Mentioned this one, death while in police custody. This is not Bayesian, I'm afraid to say. I was talking to the guy from RTI who did this. RTI is a United States-based contract research agency. The US government can't itself study all the things it would like to, and they hire out to companies that will do the study for them. RTI is one of those companies. While they did a capture-recapture methodology to identify how many people were not being reported by state and local government to the federal government, they found that that up to half of the cases of deaths in police custody were not reported to the federal government. Human trafficking, this is one metropolitan area. In this particular case, there are 15 different organizations, social service agencies, law enforcement, many different kinds. And we have multiple overlapping pictures. This is a map of Cincinnati, which I produced. It's a choropleth map, so the heat map is predicted likelihood of human trafficking in that particular geographic area. So in this particular case, one of the things we find in human trafficking, it's the victims are moved around a lot. And so access to freeways and airports and other infrastructure tend to create centers of human trafficking activity. And so you see the dark area up and to the right, on the upper right-hand part of this graph, of this plot is an airport as well as a highway hub because it's an airport, and that ends up becoming a local hub of human trafficking activity. In this particular case, I mentioned how with human trafficking victims, we have multiple different agencies. I'm working with the Michigan Human Trafficking Task Force. And what we're trying to do here is get people to hear the problem is to get the different agencies to share their data with each other, because there's data privacy and they don't all know each other. Fortunately, in the case of the Michigan group, they recently created a new smaller group of people where everybody goes through background checks, everybody gets registered, everyone's been by the lawyers and the police and everything else. So the smaller group of people who are leaders in these different organizations have been thoroughly vetted. They're being taught, I'm teaching them, and how to properly handle private data. They've seen some of this, but if their raison d'etre, their purpose for being is they're basically running homeless shelter and people are homeless because they were just managed to escape human trafficking. That's their focus. They may not necessarily know the ins and outs of building a database or how to handle private data. So we're working on teaching them that. One of the things we found useful, we've got a group going now in Piecework. My organization has a group going now in Michigan and in Fresno County, California. We're starting new groups up in St. Paul, Minnesota, and Baton Rouge, Louisiana, all in the United States. So yes, I'm terribly insular, and we really need to get this going global. But the methodology is useful. With all these different agents, and it could be a human trafficking, it could be anything. It could be the number of people who can't afford to pay their light bills or their power gets cut off. And you can go door to door and find these guys. And you're gonna have multiple agencies finding these with a little bit of intersection over each. Well, how many people are without power because they can't pay the bill? Or how many people are cutting corners? They're making that hard decision between buying food and buying medicine. We can find these, find the number of people who are impacted using these methods, but very often we're going to have multiple overlapping lists of people. By funneling all the data into a single source, a nexus that everybody trusts. So the key thing here is to find somebody that everyone trusts. Now, some places people trust the police. Some places people don't trust the police. But you need to find an agency that everyone is willing to share their data with so they can funnel it into one place. At least in the United States, with crime victims, people generally believe that the police know how to count crime victims and are willing to report to the police. They're going to withhold identifying data because they're worried about the police having some of that. We can come up with identifiers. But when all the information is funneled into one agency, now what you get is an identifier, even preferably anonymized, and then, oh, this group found that one, that one, that one. We'll give them ones, the rest are zero. Then the next group, and the next group, and the next group, and the next group. And putting all these together and noting which ones overlap, they were served by multiple groups, that's going to make capture-recapture work. And then the Bayesian method works because it isn't just 2. It's 15 or 20 or 30. Let's look at hate speech and social media as an example. So, turns out, if we want to count the people who hate others on the internet, one of the things we have to do is look at the different social media channels. We'll go through this fairly quickly. Twitter conversations tend to be very short duration, very highly reactive. Conversations that last a matter of hours. So remember, with capture-recapture, you're thinking about that time frame. One of the nice things about Twitter, in terms of capture-recapture, is stuff gets retweeted. People pick up their phones and they look. There's a very, very short time period. Also, because they have a Twitter ID, and you have to be careful about this because there are a number of different ways to identify Twitter users. There's a handle, there's a name, there's a location. They're often a mess. For haters, they're usually a mess. People try to hide their real ID, but they can't conceal their Twitter ID. So it gives us a unique ID. There's a small problem with that. We'll go into that a little bit later. We'll talk about limitations. Facebook, longer, private conversations. You have conversations on Facebook with friends, with people you've invited in. LinkedIn is the same way. Basically 2 kinds of social media then. Some that are avowedly public. Twitter is that way. Twitter is like skywriting. You tweet and everybody in the world can see it if they got a Twitter account. Whereas Facebook, LinkedIn, and many other platforms, you have to have an invited circle of people. You have to have a connection somehow. So those 2 different ways, 2 different kinds of social media. Google Trends, you don't think of Google Trends as being a social media platform, but a whole lot of folks type stuff into that Google search engine. We found this is especially useful now to find haters. This was kind of an epiphany to me. Usually when I'm using Google, it's like, what's the weather going to be like tomorrow, or is there a restaurant near me? Questions, if you will. But with Google's better natural language processing capabilities, now people simply type speech. full speech right into long sentences and things like this. They type it directly into the Google search engine. Haters will use Google Trends, and they type an entire stream of horrible stuff into the Google search engine, and what it pulls up is a list of web pages that say the same horrible things. So haters are using Google to find other haters, and it gets picked up in Google Trends. Because it's a trend, it talks about, it's Google, it talks about what people might be thinking about doing in the future. It can be more predictive. Here, one of the problems we have right now with social media, hopefully this will change. Some of the biggest social media channels, they have images. Oh, you might have comments or a caption or something like that, but it's principally images. And we do not at this time have any effective means to mine images. We can mine text, but we can't mine images for hate. You know, you can put in a picture of Adolf Hitler and think he's the greatest guy in the world. If you write that out, we can find you. If you just have a picture of him, it's going to be hard to find. So one of the weaknesses in looking at social media is we don't have good means at this time to mine images. So the way we've done this, we started out with just a few key words that we thought were associated with hate question. Oh, 5 minutes. I'll hurry up. Thank you. I'm sorry. I thought you were raising your hand. Social media. We'll go through this pretty quickly. What we found is, in fact, I'm just going to skip to the next slide. Here's an example of some key words that were found to be closely associated with hate. For example, the combination there, Sharia, not so much. And you use Sharia and you get a lot of people coming back saying, this is nonsense, and people aren't trying to do Sharia. But this particular combination of words we found very useful. If you read just the first one, so-and-so, I won't say their name, you hate America and support Sharia here, your time will come. So this particular combination gives a very pure stream of hate speech. You can, by hand, find some key words and look around and start with pulling a small sample of hate. Here's how we're going to run the process. We're going to get labeled data. We're going to use a small hand, so this is semi-supervised machine learning. We're going to get a small data set. We're going to hand label it. Once we get that, we can train a machine learning algorithm. I've used a decision tree in this particular case. Other algorithms work. But we're going to train an algorithm on the small labeled data. It's going to get more tweets, and then we're going to iterate. We're going to retrain a better algorithm as we have more affiliated tweets. Once we have this algorithm, since this is social media, we can run a loop, write a loop routine to capture new hate tweets in real time. So here's the basic structure for capture-recapture data. This is what it starts out with. In this case, these are hate type, but these are the different samples, or maybe different agencies or different things. You have multiple. You don't just have two anymore. You need Bayesian to attack this problem. So in this particular case, you've got hate types 1 through 5. You've got a Twitter ID. It's a unique identifier. And you've got mostly zeros, but every one of them has at least one. And this guy over here, he shows up twice. So he's the guy who's been captured and recaptured. A couple of different routines we're going to use. We used multimark package in R. Here's the source code. I'm not going to read you R code. It's in the presentation if you want it. One of the things we've done then is we've gotten rid of the variable names at the top. We've gotten rid of the IDs. Once you get into the actual multimark routine, you don't need the ID. You need a deduped list. So if a person writes 15 hate tweets over the course of 6 months, they only go in the list once. It's unique. Once we've identified them, they're unique. We don't have multiples, but we pick up the different ways we look for hate, different patterns of words that indicate this person is a hater. And that's how we've got, these are the multiple methods that create independent samples. And once again, number 20 down on the bottom was picked up by 2 different ways of finding haters in the Twitter sphere. A little bit of code to wrap it up. And what do we get? Well, if we do this year by year, We get the number of people. Now, the specific thing we were looking for in this case is death ideation. Wouldn't it be great to kill so-and-so? Category 1, Category 2, Category 3. We found there's a fair amount of overlap, but we use this to find population of haters year by year. It looks better in a graph. So we're able to get reasonable numbers out of this. It looks like at least in the Twitter sphere, the hate population was present in the couple 100,000 range. In the last few years, there are indications it went up a lot. It makes you wonder why there might be so many more haters now than there were just a couple years ago. We do see a very, very sharp increase in the data. That increase is enough that it probably warrants further investigation. But as you see, we can take it year by year by year. In this case, it's two different ways. One, we had 5 different ways, 5 different machine learning algorithms to identify haters. And all the different algorithms, they caught some people and not others. So we put them all together and saw where they overlapped. That gave us capture-recapture. We did it by year, and now we've got a population trend. Conclusions. Here's what the output looks like from multimark. So in this particular case, this was for 2016. We've got about 130,000 haters in this particular variety of hate in the Twitter sphere, plus or minus maybe 40,000 is the standard deviation. So what is this good for? What we're doing, we want to get back to this key notion. We're going to count hard to count populations. We're going to do this with multiple independent samples. Bayesian allows us to take multiple samples. It allows us to do repeated analysis and repeated measures. It lets us do time series analysis, and it pushes all our standard deviations down, so it gives more accurate estimates. And of course, the more times you measure, the better the priors get, and so it continues to get better, it actually gets stronger with subsequent samples. Lots of different applications, data for social good, we mentioned a couple of those. Indications from our example show that social hate population is fairly steady with a sudden recent increase. Some closing thoughts. Why we're doing this. Thank you. And questions. And we're going to.
It's really interesting. So what I want to see that methodologically repeated measurements gives that idea that we are having much more data point.
Yes.
And is the idea behind to make a good relation between these other factors and
yes. Data point? Let me repeat that question just to make sure it gets picked up by the mic. So if I understand the question correctly, we're going to have repeated measures. Is the idea that we're going to get better performed by having more and more points?
More points. One you are having much more.
Yes.
Much more relation you can explore.
Much more of a relation. Yes.
Simultaneously, when you're talking about the capture-recapture, we are attempting to make the reduction of the duplicate observation.
Yes.
So, but what is the intuitions to make these two different methodologies together?
We want the methodologies.
Different kind of object weights.
Different kind of objects, different kind of measurements. The key thing is that they have to be different ways of measuring the same thing. For example, if it's suspected I came down with measles, I would go to the doctor and they would look at 15 different indicators. But they all indicate measles. What we want to have is multiple ways of capture the same thing. So we want to diagnose the problem and have multiple ways of capturing that. That helps define the population also. Let me go take a question back there.
Do you know if these Twitter IDs are human or not?
I'm sorry?
Do you know if these Twitter IDs are human or not?
Do we know if these Twitter IDs are human or not? No.
Okay.
However, how many of them are bots? We haven't looked into that. Let's be perfectly frank and honest. However, remember that we deduped. So if we did it by population, there have been some studies that indicated 40% of Twitter traffic is bots. But those bots only make one row, and they're a small population. And at the same time, behind each bot is someone who programmed that bot, and they might reasonably be described as a hater. Yes?
Question. Thank you for your talk. It's really interesting. Is there an idea that hate speech changes over time? Like a fish,
Yes.
species won't change generally over time. There will be some evolution over long time periods, but what is classified as hate speech may in fact be a moving target.
Moving target. Is hate speech a moving target? Absolutely it is. We talked about in capture-recapture, you got to get the time interval right. One of the nice things that the mixing time interval for Twitter is seconds. So that's helpful. But how long does it take before the hate population changes? And we're using text to detect them. How does the language change? Hopefully slow enough that there aren't tremendous changes in language, but yes, there will be glacial, maybe faster, shift in language and types of hate. One of the things we do when we, it's not in the presentation, when we look at individual types of hate, people who hate Muslims, people who hate fill in the blank, I'm not going to go down the list. Muslims, sadly, are getting a lot of hate speech these days. That's changed recently. In the last 15 years, we've seen a big uptick in that, so that Muslim hate has, at least in the United States, is now higher than Jewish hate for the first time in recorded history. We'll see if that lasts, or if, we can see the changes in the population, in subgroups of the population. Is that showing changes? There are changes in, we can see the changes in the targets of hate. And that gives us an idea that, yes, the population is changing some. One of the requirements for capture-recapture is that you have a closed population. And that shift is something that you have to measure and watch out for. It's a very good question.